In this video, we're sticking with our identities, and we're going to talk about the half angle identity. So we talked about earlier the double. Right, so if we double an angle, now we're just doing the opposite. We're halving an angle. And these formulas look really complicated, but they're kind of the reverse of the double angle identities. All right, so the identity for a half angle, so in each one of these, I'm taking an angle and dividing it by 2. They're actually really similar. Again, you don't have to worry about memorizing these formulas, but again, it ends up being similar to do both of these because the formulas look really similar. So for the sine of an angle divided by 2, I take 1 minus the cosine of that angle divided by 2. So this is the fraction, and it's all going to go inside of a square root. And then I have a plus or minus because I'm not really sure if I take half of an angle, is the sine still going to be positive? Is it going to be negative? Whatever. That's something you kind of have to figure out. All right, but the formula for cosine is similar. The only difference is I add instead of subtract. So if you can do the sine ones, you can do the cosine ones. You're just putting a plus sign instead of a minus sign. All right, so let's find sine of 15 degrees. So just like when we did the double angles and the sum in different angles, the kind of first thing you need to do is be able to rewrite this using our nice angles that we can do using our unit circle. And in this case we can, because sine of 15 is the same as sine of our 30-degree angle divided by 2. So 30 is the angle we're taking the half of. So then we can say this is plus or minus the square root of 1 minus cosine of 30 over 2. And again, the reason we do this is because cosine of 30 is on that unit circle picture we have. We know that that is the square root of 3 over 2. And if all you wanted was a decimal approximation for this, you could just plug this in. As long as you're really careful with parentheses and things, you could plug that in a calculator. But there's some ways to simplify. So if you look at the final answers for the practice for this section, they'll be written in a lot of different ways because they're kind of different levels of simplifying, just to kind of show you different ways your final answer can look. So you might see some answers that look like this. You kind of just plug that value in and you're done. One thing you can do to help simplify is we're going to have this complex fraction here with a fraction within a fraction. So what I'm going to do is I'm going to multiply the top of this fraction by 2, because that'll cancel out that kind of fraction on the right. But if I multiply the top of a fraction by 2, I also have to multiply the bottom of the fraction by 2. So this is going to turn into, so this big square root, I get 2 minus the square root of 3 over 4. And that's because this 2 distributes in. 2 times 1 is 2. 2 times this fraction, the 2's cancel, and I get the square root of 3. And the bottom 2 times 2 is 4. So that's another way you might see the answers on the solutions for this section, this learning objective. But the final way you might see it is I can split up square roots over division. So this division bar, I kind of split this up into 2 different square roots. And on the bottom, we know the square root of 4 is actually a really nice number. It's just 2. So those are kind of the 3 different ways you might see your answer. Just kind of plugging in that cosine value, getting rid of the complex fraction, and then fully simplifying the bottom. So all 3 of those will show up on the answer guide. So it kind of depends on how much you want to simplify. For the exam or a test or something like that, these 2 are kind of the main ones I'd be looking for, with some simplification to kind of get rid of that complex fraction. But as you go through the practice, you can kind of work on simplifying these and make sure your answers match those on the answer guide. So for your turn, find cosine of 15 degrees. And this is what you should come up with. Really, the only difference between this problem and the last problem is you're going to have plus signs inside that square root the whole time, because that's the formula for cosine of the half angle. So everything's pretty similar. Just that plus sign, so you can multiply by 2 over 2 here, split up the square root, and then this is the kind of fully simplified final answer there. One thing I forgot to mention in the first example is we start off with this plus or minus in front, but we know 15 degrees is in quadrant 1, so we know it's the positive answer. So our answer is just the positive version with that answer in that red box. You know that sine of theta equals 3 over 5. Find cosine of theta over 2. We know every single time we want to find cosine of some half angle, we have to use this formula. Plus cosine of theta all over 2. So we have to use that formula, which means we have to plug in the cosine of the angle, and we don't have that yet. But this is something we've done a lot throughout the semester. If sine is 3 over 5, I can make this right triangle, label one of the angles theta, opposite's 3, hypotenuse is 5. And we've seen this triplet a lot. If there's a 3 and a 5, the missing side using the Pythagorean theorem is going to end up being 4. And that tells us that the cosine of this is adjacent divided by hypotenuse is 4 over 5. All right, so now we're going to get cosine of theta is 4 over 5. And on the answer guide for the practice, you might see some that look like this is the final answer, but we can actually simplify this a bit, just like we did in the previous one. I want to get rid of this complex fraction, so I want to multiply it by 5 to get that denominator to cancel out, which means I also have to do it on the bottom. Right, so I'm going to get plus or minus 5 times 1 is 5. 4/5 times 5, the 5's cancel, and I get 4. And I kind of forgot to make this square root go over the whole thing. And on the bottom, 2 times 5 is 10. And then I can simplify a bit. 5 plus 4 is 9. Right, so you might see some final answers that look like this. But again, I can split up the square root over that division. And the square root of 9 comes out nicely to 3. All right, so if sine is 3/5, cosine is plus or minus 3 divided by the square root of 10. All right, if sine is positive, we're in quadrant 2 or 1. And if we cut those angles in half, it's probably going to end up in quadrant 1. So chances are this final answer is just the positive version, 3 divided by the square root of 10. All right, but really similar to some problems we've done before. All right, I'm given sine, so I use that to figure out the cosine, and then just plug everything into the formula and simplify. All right, so here's a similar one with just the function switch. I'm trying to find sine, and I'm given cosine. All right, so go ahead and try to do that one. And this is what you come up with. You don't actually have to do the SOHCAHTOA stuff because we've given cosine. That's directly what plugs into the formula. So we're just putting that 4 over 5 there. Multiply the top and bottom by 5 and simplify a bit. And again, you've split up the square root. The square root of 1 is 1. All right, and the very last thing, if cosine's positive, you're in quadrant 4 or 1. Or if you're in 4 and you cut that in half, you're going to get in quadrant 2, where sine's positive. If you're in quadrant 1 and you cut it in half, you're still in quadrant 1, where sine is also positive. So the positive answer is going to be our final answer. Just 1 over the square root of 10. And the final multiple choice question, which of these angles could you find the value of using the unit circle on the half angle formula? So which one of these can you rewrite as half of one of the angles that we already know how to do?